Hello, in this lesson, can we learn how to reflect our fingers on the coordinate planes? But before we start the reflection, can we review the coordinate plane itself? So we have a graph here, and in this graph, can we first study some properties of the graph itself? So here, on this right side, we call this the first quadrant. Then this one, we call it the second quadrant. Then this one is the third quadrant. And this one is the fourth quadrant. Then from there, now that you know the quadrants, can we start some properties of those quadrants? And the first thing is the scale of each of the quadrants. And the first one here, the first quadrant, if you check well, you realize on the x-axis, the scale is positive, and also on the y-axis, the scale is positive. So on the first quadrant, the scale from both x and y are positive. On the second quadrant, the scale for y-axis is positive, but the scale for x-axis is negative, as you can see. On the third quadrant, both the x and the y scales are negative. And then on the fourth quadrant, the x-axis scale is positive and the y-axis scale is negative. So from there now, with that knowledge, we can try to plot or to reflect some figures on this Cartesian plane. Cartesian plane is simply the graph itself. So the first rule of reflection is that if you are told to reflect a finger on the x-axis, the x coordinates of that finger remain the same, but the y coordinates change to negative. So for example, if you are told to reflect a triangle which has vertices M, B, and C with these coordinates, all the y coordinates will change to negative, but the x ones will remain the same. So this is the rule for reflecting a finger on the x-axis. So let me copy these coordinates of the triangle on my board. Then we can calculate or we can find the new coordinates of the reflected finger. Then we can plot them in the Cartesian plane. So these are the original coordinates, and as usual, the rule is reflecting on the x-axis, the x coordinates remain the same, then the y coordinates change to negative. So here in this one, we have this is the x coordinate for the first point, then this one for the second point xy, then this one xy for the third point. So we need to retain all the x coordinates but change all the y coordinates to negative. So now the reflected A will be x will remain the same, but now y will change to -1, and B 4 will remain the same for x, then we change y to -1, and then C 3 will remain the same because it's the x, then 4 will change to -4 because it's the y one. And now that we have the coordinates of the original triangle and the reflected triangle, now we can plot them on the Cartesian plane. So how do we go about that? We have the points of the original finger. We start by plotting it, which is 1, 1. For the original was 1, 1. Then the second one was 4, 1. B was 4, 1. And then C was 3, 4. 3, 4. So now we have plotted the original triangle, and then we reflect it on the x-axis. But here we already calculated the coordinates, so we just plot them direct. So we have the reflected A will be 1, -1. So it will be 1 on x, then -1 on y. I plot it there. And then it will be 4, -1 from B. So 4, -1 from B. And then for C it will be 3, -4. For C it will be 3 on the x, then -4 on the y, like that. And as you can see, we have reflected that triangle on the x-axis. So the coordinates for this one, we have already calculated them. They are these ones. And as you can see, the finger is inverted. That is the logic of reflection. When you reflect, something is kind of like you are looking it at the mirror. So it becomes inverted. And here, the x-axis is the mirror line. So can we try to reflect the same original triangle now, but in the y-axis? So the rule for reflection on the y-axis is that the x-coordinates change to negative, but the y-coordinates remain the same. So that's the rule. So for example, if you are told, of course, to reflect our original triangle, it was 1, 1, 4, 1, and 3, 4 on the y-axis, this is how we go about it. So these are the original coordinates of that triangle. So we can calculate the reflected coordinates because we know the rule. When we are reflecting on the y-axis, x coordinates change to negative and the y coordinates remain the same. So in our case, we have this as x, this is y, this is x, this is y, this is x, this is y, like that. So from there, we can change the p to the reflected one, which becomes now -1 because we are changing the x ones to negative, then +1 for y. Then for q, we do have -4 for x, then 1 for y, and then for r, we do have -3, and then 4. Now that we have the original coordinates and the reflected coordinates, we can plot them in the Cartesian plane. So the Cartesian plane, we have go back here. We have the original triangle, which was 1, 1, then 4, 1. I think the second one is 4, and then the third one is 3, 4. 3 and 4. So we have plotted the original triangles. Then can we reflect it on the y-axis? Of course, the y-axis is this one. So the first coordinate becomes -1, 1. So it becomes -1 on the x-axis, then 1 on the y. Let me put it there. Then the second one becomes -4, 1. -4, then we have 1. And then the third one becomes -3, 4. -3, then 4. Yeah. And that becomes the reflected triangle on the Cartesian plane, like that. And here I made a small mistake here. It should be at 4, not 3. But that is something you can correct. So this is the reflected triangle. This is the original triangle, and that's how we reflect fingers on the y-axis. But sometimes you can be told to reflect a finger on a specific line. For example, in this case, you can be told to reflect a triangle on the line x is equals to 2. So how do we go about that? Well, the first step is to plot this mirror line where x is equals to 2. And of course, this means where the y-axis cuts the x-axis at point 2. So I can come here and plot, that point will be here. So I can plot that vertical line here, and that will become our mirror line. So if I plot it like this, as you can see, this is the line where this line cuts the x-axis at point 2. That becomes our mirror line. So the second step, of course, is to plot the original triangle, which we do have as 1, 1, 4, 1, and 3, 4. So I can just plot that one automatically. So it's just our normal triangle we have been plotting all along. So if I do is 1, 1, that's the first point here. Then the second point is 4, 1, 4, 1, somewhere there. And then the third point is 3, 4, 3 and 4, somewhere here. like that. That is the original triangle. Then the rule for this reflection is if you are told to reflect a finger on a specific mirror line, then that mirror line is on the x-axis. The formula becomes first the mirror line, we can call it A. So the formula becomes 2 into A minus x. I'll explain this. This A is the value of the mirror line, and in our case that value was 2. But then this 2 outside the brackets is, you see, in reflection, it's kind of like you are dividing a finger in at the center. So it will go, for you to move from one point to the reflected point, you'll have gone twice the distance. So that's why we have this 2 here. So now the final formula in our case will be 2 into this A. We already have it, which is 2, but now minus x, which now will become, we can apply this now in our original coordinates where we have, the question was, we have D has 1, 1, then E has 4, 1, D has 1, 1, then E has 4, 1, and then we have the last one as F 3, 4, F S 3, 4, like that. Then we apply this formula for all values of x. So that's x, that's y, that's x, that's xy. So we apply this formula for all values of x, but y remain the same. I forgot to put that here, y remains the same. So here it becomes, this is just like saying 4, 2 by 2 is 4 minus x, so it becomes 4 minus x, comma, y. And then we apply this formula in this one. So now D reflected becomes 4 minus the value of x, which is 1, so it becomes 3, then y is 1. Then that one for E, it becomes 4 minus this 4 for x, which is 0, and then the value for y remains, which is 1. And then for F reflected, it becomes 4 minus 3, this one for x, which now 4 minus 3 is 1, and then the value for y remains. And now we have the original coordinates, we have plotted them, and we have the reflected ones. We can plot them. So the first one is 3, 1, but we can plot it here. 3, 1, somewhere here. Then the second one is 0, 1. The second one is 0, 1. So we can plot it here. It is 0, then 1 somewhere there. And then the third one is 1, 4. The third one is 1, then 4 somewhere there. And that becomes the reflected triangle. We can fill it like this. And as you can see, the line divides the two fingers at the center. And so in this case, the logic of that two we were talking about, for example, to move from this point all the way to the original point here, you'll realize you'll have to move twice the steps. So if this one was, let's say on the x-axis, this one was point 1, to move to this point on the other side, you'll have to add 2 units to reach to the point here, which is now 3. So that's how we go about the reflection. If you have any question, if there is a place you don't understand, you can leave a comment, you can ask me any question, I'll try to answer. And bye for now, let us meet in the next lesson.